Hello everyone, today we will be going over the concept of hash tables, and without any further hesitation, let's get started. Let's imagine that we are in a school with many lockers. Each locker has a unique number and can store one item. Hash tables work similarly to these lockers in general, where each locker represents a unique key value pair. And what does that mean in particular? Well, key value pairs represent where each locker is considered an entry for a hash table, and there is a number or indicated as a key that is able to access that item inside of that locker. And typically this is also denoted as a hash function in general. So hash functions, layman's term to put it, is actually saying it's an array that is kind of more robust compared to typical arrays, because you have a key value pair relationship between the two. And it's like a special rule that tells you which locker number to use based on the key. The lockers in general are considered slots in the array where the data can be stored. Sometimes different keys may lead to the same locker, causing a collision, which we eventually try to prevent in that case whenever we are having different actions of storing, searching, or retrieving as well. And for us to be able to handle collisions will be in the case of, for instance, if we put into the locker metaphor, for instance, if there are two students that are given the same locker number, there are techniques to prevent collision, such as chaining using multiple lockers linked together, or open addressing, where we find another empty locker and use it to handle this. So we can just have a temporary hash table or hash map to be able to actually build up our whole indexing system to be able to actually store and retrieve different forms of data using hash tables / hash maps. And overall, they provide a very efficient and fast space and time complexity. The average time complexity for this is denoted as O of 1, but space complexity being O of n. And there are different ways of creating different hash functions as well. Ones can use maps and sets to be able to create their own hash tables. Just the key difference between the two is depending on their application. For if you want to store multiple items within your hash table or hash map, you would typically use maps. But then if you also are focusing on specifically one item to be stored inside of your hash table, you would typically use a set. And so in general, this is just the overview for hash tables as well. We get to know based on an example. So we see in one case when we're using an unordered map, which is part of the STL library, to be able to build out our hash table. And we're able to have three different elements of integers that we've already indicated right over here, indicated by a string. So these two parameters would indicate a string, hence the string over here, and an integer accordingly here. So we have 1, 1, 2, 2, 3, 3, and we just output the following as well between the relationship of the when we've actually stored all together. So we would have the string and the integer, string and integer, string and integer accordingly, depending on what has already been built and put inside of our hash table, also indicated as a locker, in this metaphor in general. And so also, for further context as well, to be able to go over the advantages and disadvantages of such, just going over the disadvantages. So depending on the context of your application for hash maps, there's quite a bit of memory consumption in general, and it's also really just in contrast with managing collisions when it's dealing with that memory management. But overall, hash tables are also really applicable in terms of real-world settings for data indexing and handling caches as well. So yeah, this is just a general overview for hash tables, and now let's head over to our series of practice problems. So now we are tasked with the following problem. We will now implement a hash table with separate chaining using the following and state differences for each. We are first going to build a hash table using a map. Then we're going to be building a hash table using an unordered map, and then using a hash table with an unordered multi-map. And the next phase, what we will be doing is that we will be using a set to be able to build our hash table, an unordered set to build the hash table, and then an unordered multi-set to build the hash table. We will insert a key value pair into the hash table, retrieve the value associated with the given key, and finally remove a key value pair from the hash table. We will print out our hash table's elements accordingly while we are updating this. And now let's go over our first problem. So overall, what we will be doing is that we are going to be focusing on developing our hash table using a map. So overall, the first thing we need to do, as usual, we are going to import our necessary libraries that we are going to use. So aside from iOS Stream, I'm also going to include a map, and I'm going to include a vector. Now, a vector is actually a useful tool that we use in C++. It allows us to be able to take elements and be able to actually use them to loop through our given data structure to be able to output and print and or delete or move. It's able to put all of our elements in a list accordingly. And there are really two parameters that really go inside of a vector, but I will go further in depth as we move forward. So, first thing I'm going to do, we're just going to be using the main function just for the sake of time in particular, because these libraries have already been built out for us to be able to call upon and use the principles of the hash tables accordingly, so that we know exactly what to do directly, and we can just interface and just put them directly inside of our main function. Saves us so much time versus just building out everything from scratch here. And also do not forget using namespace std. So the first part that we're going to do is that we're going to first initialize our map. Our map has two parameters by general principle. I'm going to put in a string and an integer, and I'm going to call this omap. There we go. And then we will insert key values. So I'm going to go omap. And since we have a string, we're going to go 1, hence the quotations, equals to 1. Right here for the integer. And let's also be sure that we have the requirements. Insert key value pair. We're going to do that. I'm going to put 2 more as well. So 2, and then 3, 2, and 3, and we will retrieve the key. We will retrieve the value of the keys, and we can just work with 1. So I'm just going to put out value for 2 in that case. Omap. And then all we got to do is just call upon from right here. Simple in this case. Then we're going to remove a key value pair from the hash table. And so I'm going to do remove key value pair. And what I'm going to be doing is omap dot erase. And we can just call upon the string that we have over here. And we will output our hash table, and we'll do this by using a vector for pair string int, because we are taking into consideration the parameters we made with our map in this case. And I'm going to call this vec. Omap dot begin, and then omap dot end, and that's how we initialize our vector that we're able to call. For the next part, this part is going to be displaying by using a for loop. And we can use the same type of syntax that we did before, where we have int I equals 0, I is less than the vec.size, and then we increment the vector accordingly. Then we will output vec I.first, vec I.second, because it's just going in a continuous for loop that we have over here, and then we return 0. So there we go. And so we've already done that. We retrieved one of the key value pairs that we were looking for explicitly, and then we remove a key value pair accordingly. And we are then able to display the rest of our hash table accordingly, even after removing 2 that we have erased in this case. So let me just zoom out of here, and I'll put this as well in the discussion. There we go. And now let's head over and do our second problem. And now let's focus on creating a hash table using an unordered map. Or you can call this a hash map for the most part, depending on whatever context that you put it in. But the point in principle is this is what we have. So to be able to kick things off over what we have, let's go further in depth. So we will also include, after we include IO stream, include unordered map. And then we will also include our vector, useful to be able to help us print out everything. And we will also include using namespace std for the sake of convenience. Then call upon the main function, and we will do unordered map. And let's go with the string and int, much like what we did last time. And I'm going to call this umap. Now we are going to be doing the exact same thing that we did before. Then we continue the following. We will insert key value pairs, retrieve values by key, remove key value pair, and converting unordered map to vector for indexed access, and display the values. So what we will be doing is that to insert, we're just going to call upon this, and since we have a key value pair, what we will be doing is 1 is equal to 1, and then we'll do the same thing for the other ones as well, except for 2, 3. This does look like the other one that we have already done, except we're using unordered. Count value for 2. And this is great practice anyway. 2 end L, and then umap dot erase v2 here, and converting what we have to a vector so we can output pair string int, and I'm going to call that vec, and then I'm going to put in umap dot begin, umap dot end, putting it there, and then we display the values by doing our for loop for int I is equal to 0, I is less than vec dot size, and then plus I. And we'll output our vector I dot first, vec I dot second, and we'll end everything by end L. And finally return 0 because we're working with an integer in this case. And so yeah, let's just clean this up and make sure it's running smoothly. There we go. Does the same exact thing over here, just like what we did before. And it's by general principle, feel free to take a screenshot accordingly. And then let's move over to our multi-map problem. And now for our unordered multi-map problem. So the first thing that we usually do, as usual, we include our libraries that we are going to call iostream. Include. This time we're going to be using an unordered map for the flexibility to be able to create a multi map, and then we'll also include a vector to be able to loop through the rest of our hash function, or hash table per se, and then using namespace std int main right here. Now we're going to first redeclare unordered map, but we're going to call it multi-map. We're going to have a string int u map. So we're using this multi-map from the there we go. We're using this multi-map from this library that we've already set in place, and going to first do our function is that we're going to insert, retrieve, remove, and then I'll display. So insert, the way we do this is going to be umap.insert, and for make compare, there we go, 1 and 1. And this is used for multi maps. So 2, 3, 4, 2, 3, 4, semicolon, semicolon, semicolon. Except for this time, we're going to be doing this. We will be, let's just take this 4, and this time let's call this 2, and this time use 22. So this is where multi-maps go in. Now the next part we're going to be doing is that we will retrieve. The way we're going to be doing so is that we will retrieve the values by key. And this time we're going to be using a for auto loop. So to do so, we go auto range equals umap equal range by 2. And then we're going to output values for 2. And then for auto it is equal to range dot first. It doesn't equal the range dot second. We're gonna go through. So it does operate the same context for whenever we have a vector. In this case, it's just that we are getting the specific values that we need for our multi map that we have for our hash table in general. Second here, or hash map. And then we'll finally have count end. Then the next part we're going to be removing, and we do so by umap.erase. And we can just call 2, so we'll erase one of the key value pairs. And then we will display by using our vector pair string int, and then vec umap.begin, umap.end, and then display. We're going to use this for loop for int I is equal to 0, I is less than vec.size, and then we increment with I, and then we're going to output the rest of our vector. So vector I dot first, vec I dot second, and L. There we go. And finally, since we have an integer for main, we will return 0. So let's build this to make sure this is all good. Well, it looks good right here. And now let's return. Yay, we did that. And it looks like whenever we erase 2, it actually gets rid of these 2 elements that we already have for integers. So they're all grouped together, and that's just the context for the multi-map. So feel free to take a screenshot for this exercise we have. And now let's move over to our sets. And now let's head over and focus on building our hash table from sets. So first thing we need to do as usual is that we need to include our library. So after we include the basic IO stream, also depending on whatever text editor you're using, I'm also going to include, or IDE, I'm also going to put in include on put in a set. In this case, there we go. And then we're also going to include a vector. And using namespace, std. And we have the main function right over here. We're going to call upon the necessary library. So first things first is we're going to have a set of strings. And I'm going to call this a word set. And a word set. So what we'll do, we'll insert, retrieve, remove, and then we're going to display. So first thing we're going to do is that we're going to have word set dot insert, and since we have strings, we can call this apple. Banana, orange, we don't need that. If we have a duplicate entry, it will be ignored. And so what we will be doing is that we're going to retrieve a specific word in our set. So word set dot find banana, if it's located. Then we're going to have an edge case where if it is not in the word set at its very end, we're going to say following. So actually, sorry, to clarify, we're saying that if it is in the word set, this is just a weird symbol, just saying the word set dot end is stating that there is nothing in general. We're saying that we have retrieved. So therefore it's saying if it does not equal to the fact that there is no banana, meaning that there is, we're going to retrieve where banana is located. We're going to end that. Otherwise, we can say count banana is not in set. Actually, it would be easier if I just did this. So let's move this. There we go. Now we're going to remove. So we do word set dot erase. I'm going to find the specific one, banana. I'm going to say banana has been removed from set. Then we're going to display by using a vector string words word set dot begin word set dot end, and we're going to print by count words in the set, which is sorted for int I is equal to 0. And then we're going to have I equal less than words dot size. We're going to increment as well throughout our whole set, and we're going to output the words of I for our set. Notice the difference from what we did earlier in our maps compared to the set. And then we're going to count end L, and since we have an integer in this case, we will return 0. Now just double check, make sure it's all built. Okay, I misspelled a couple things. There we go. Let's see if this actually works. Yep, it does the same thing right over here. This part makes sense. It retrieved banana. Banana has been removed from the set. And words. And I'm going to check my spelling over here. There we go. Ta-da. That's better. Okay, and so this was, so this is how we build a hash table from a set directly, in particular. we've done the necessary actions of insert, retrieve, remove, display, and we have done so in our terminal as well. And now let's create our hash table from an unordered set. So the first thing we do, as usual, is include our library. So after include iOS stream or whatever IDE we are using, we're going to do include unordered sets. Then we will be including our vector. And then using namespace, std, and then we'll have int main here to start. Then first thing we're going to do is that I'm going to have unordered set of integers in this case, and we're going to have a number set. Then we'll do function insert, retrieve, remove, and then display. So insert number set, done. Insert 10, 20, 30, 40. Make this 20, 30, and 40. Then retrieve. We will have the following. We're going to go auto it is equal to number set dot find 20 in particular, and we are going to have a for loop for, or sorry, our Boolean statement for if it equals number set dot end, where we've already scanned it, and then we're trying to find it. Then we're going to say found, sorry, and L, and then in this case we would say that number 20 has been found, and L. And for us to be able to remove, we're going to go number set dot erase 20, and we're going to say 20 has been removed. And L. There we go. And then for display, we're going to have a vector int numbers number set dot begin number set dot end, and we're going to output numbers in unordered set, and we'll do a for loop for int I is equal to 0, I is less than numbers dot size plus I. Then we will output count numbers of I for each index, and we will have a space accordingly for each one. Going down, count and L. Finally, return 0 because we have an integer in this case, and 0 is our base case. Yep, insert, retrieve, remove. Let's make sure it's all built. Good job. And now we will print. Number 20 has been found, as we've already said. It's already inserted. We already have this Boolean condition to be able to check for our edge case, and then we also remove. 20 has been removed. And look at this, numbers in unordered set, 40, 30, 10. And program is ended with exit code 0, and everything is already checked out for our unordered set. Hooray! Now the next part, let's focus on an unordered multi-set. There we go. Let me just, okay. That should be good. And now let's focus on an unordered multi-set. So for us to be able to get started, what we'll be doing as usual is include our libraries. So obviously to start with, depending on IED, iOS stream. Then we'll also include an unordered set. Then we will also use a vector. So we're going to include a vector. And then using namespace std int main for a function. And then we're going to have an unordered multi-set of integers. And I'm going to call this a number multi-set. Then we're going to have for functions insert, retrieve, remove, and display. Insert. So we're going to have number multi-set dot insert, and since we have integers, I'm going to go 10, 20, 30, and 10. Yep. Duplicates are allowed. Then we're going to retrieve by doing int count equals number multiset dot count instances of 10, and then we're going to output the number of 10 occurrences. Count and L, taking this variable here, putting it there. Then we're going to be removed by doing number multiset dot erase and number multiset dot find instances of 10, so we get rid of all of the 10s that are inside of our multiset, and count. But this time we're going to do one occurrence of 10 removed from the unordered multiset, because unlike last time where in our maps we would erase all of a specific value that we will find if we get rid of that group, we're going to remove one specific occurrence, but we'll see in the results as well. And L, and then we're going to be displaying, we do so by vector int numbers number multiset dot begin number multiset dot end, and we will be printing out everything. So count numbers in the unordered multiset for int I is equal to 0, I numbers dot size dot I, count numbers I here, and count and L, and finally return 0. So I'm making it unsigned line to int. That should be an error that we can ignore. Both succeeded. And yes, so it does behave accordingly. Implicit conversion loses integer precision. So the warning is really because this we need to make this an unsigned integer, so I'm going to call the size t in this case, so that way there's no constraint. There we go, and should work. There we go. Yep, it does the same thing, and we got rid of the whole warning. So yes, this is our unordered multiset solution, highlighting the whole functions, and you folks can take a screenshot to be able to go further in depth and understand more at the same time. Let me just zoom in slightly. There we go. And so yes, this was the unordered multiset. Hey everyone, thank you very much for taking time to watch this today. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions as well, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.